So in geometry, as well as in other math classes, there is another way to measure angles other than the degree, which is probably what you're used to already. But we are going to talk about something called the radian. Okay, and a radian is a way to measure an angle. Okay, normally used in physics and calculus and pre-calculus and in other higher order math classes. But the idea is not very hard to understand. So notice we have a circular looking thing here where this length is called the radius. Okay, now if I took that length, the radial length, and I laid it along the side of this circle. So this arc length here, the length of that arc is the same as the radius. Okay? If I were to draw an angle from the end of that back to the center, this angle is defined as 1 radian. That is 1 radian measure of an angle. Okay, it's a ratio of the arc length to the radius where they happen to be the same. Okay, that is 1 radian. Now if I continue laying these radians along the edge of my circle, I have another radius length to here, and then I have another radius length to here. It turns out that there are exactly 3.141592 radians to make it exactly to 180 degrees. Okay, exactly pi. There are exactly pi radians. 3.14 radians to make it all the way around to 180 degrees. And if I were to continue to lay radians along my circle's edge, by the time I got all the way around, I will have gotten exactly 2 pi radians all the way around my circle. So there's 6 radians to there, here's 5 radians, here's 4 radians, and so on and so forth. There are exactly 2 pi radians all the way around a circle. So you might be asking, yeah, so what? Well, this is what. If I have the degree, if I have a degree like 30 degrees, the degree is equal to pi over 180 degrees. Okay, this is the ratio. There are pi radians for 180 degrees. That's equal. That is a true ratio. That gives you half of a circle in either way. Okay, or if you want to convert to the other way, a radian would equal 180 divided by pi. Okay, if you were trying to go from radians to degrees, we would use this ratio of 180 divided by pi. Okay, so if we're changing a degree to a radian, we multiply by pi over 180 and reduce. And if we're going from a radian to degree, we multiply by 180 and divide by pi. So let's see. Oh, look at that. I have some problems down here to test it on. Convert from degree to radian. So negative 200 degrees. So if we were to draw this, and you don't have to, but just to draw it for fun, negative 200 degrees is over here. Okay, because negative 180 is at the right here. This is negative 180. So I would do negative 200, convert to radians, times pi divided by 180. Now I have to do, well, this, negative 200 pi over 180. And now I want to find a common multiplier between 200 and 180, because we need to reduce this as much as we possibly can. Okay, so let's reduce it. I know they both have a 10 in common. Ooh, that's not what I want. I want 10. So if I divide them both by 10, that's 20 pi over 18. Okay, and I believe 20 and 18 still have a common multiplier of 2. So divide them both by 2, and that's 10 pi over 9. And that is as simple as you can get. 10 and 9 have no more common multipliers, so I cannot reduce that anymore. So negative 200 degrees is known as negative 10 pi over 9. Okay, let's look at it with 600. Okay, 600 is more than one revolution. Okay, 360 goes all the way around, so 600 goes more than more than one revolution. In fact, it's all the way over to here, I believe. So what is that 600 degrees as a radian? So I take 600, times it by pi, and divide it by 180. And now I reduce. So I know that the zeros can cancel out. They can both be divided by 10. Okay, 60 and 18. Let's see. I know they can both be divided by 6, right? Because 60 is 6 times 10, and 18 is 6 times 3. So that's 10 pi over 3. And 10 and 3 can't be reduced anymore. So that is my radian angle measure for a 600-degree angle. Okay, so that's what we do when we go from degrees to radians. Now how about we switch that up and go from radians to degrees? So how about 13 pi over 18? So I want to multiply this by 180 and divide it by pi. Okay, that way the pi's cancel out so nicely that it is super duper fun. Now there's two ways we can actually multiply 13 times 180 and get a big number, or we can look and see if we can reduce anything before we multiply. And I know that 180 divided by 18 is 10. So the 18 and the 118 divide out, and I get a normal angle measure of 130 degrees. So 13 pi over 18 is also known as 130 degrees. So when you're converting from a radian back to a angle, we multiply by 180 and divide by pi. That way the pi's cancel out. And then let's see, let's reduce this. How many 4s go into 180? And I believe that's 45 of them. Right, half of 180 is 90, and then another half is 45. So 5 times 45 in the negative is negative 225 degrees. So negative 5 pi over 4 in radians turns out to be negative 225 degrees, as well as degrees, of course. So if you want to go from radians to degrees, you multiply by pi, 180 over pi. And if you're going from degrees to radians, you multiply by pi over 180.